Hi, Spring fans. Welcome to another installment of Spring Tips. You know, I've been really caught up in this whole wave around AI, artificial intelligence. Clearly, the search for actual intelligence hasn't gone well enough, and so we've switched to artificial intelligence. And I get it. I understand. I love artificial intelligence. I love the ecosystem around it, and of course, I love Spring AI. I love Spring AI, and Spring AI gives you support for the whole RAG pipeline, the retrieval augmented generation pipeline. The idea that I have data, I want to read that data, I want to then use that data to inform the requests that I make. Where do I store that data? You're going to hear people talk about vector databases. Vector databases are all the craze. They're all the rage right now. Everybody's sprouting seemingly a new vector database module in their existing support. So now you can use everything. I mean, Redis has a vector database. Elastic can do vector databases. Neo4j can do vector databases. Postgres can do vector databases. I think Oracle can too. I mean, just everybody has a vector database now. And it's no surprise. It's actually not all that difficult to see how this gets done. And I am very, very happy to see this. But it's worth remembering that vector databases can be used independent of AI, okay? And so in today's episode, I wanted to take a quick look at using a vector database and seeing how it does what it does and why it does what it does. Vector databases, again, you have a wealth of choices, and so I couldn't begin to cover them all, but there's a lot of really good ones, and the ones that I'm going to look at today are just those, or just one of those, actually, out of many that are supported by Spring AI. Spring AI has integrations for, I don't know, a dozen, something like that, like a number of different vector databases. And there are others out there that are just as easy to use. I just did the Google Cloud keynote for the Google Cloud Next conference, and in it, we demonstrated Spring AI and other modules in Spring AI talking to AlloyDB, right? Worked just fine. It was easy. But AlloyDB is Postgres, so I suppose this probably would have worked. I wasn't sure back then if this was the equivalent of what we were doing in the PG vector store support, but probably was. Either way, we just did the SQL directly. Super easy. Vector databases and the functionality that enable them are really accessible, especially if you already understand the database underpinning it, right? But there are a good many alternative vector databases as well that are focused only on that domain, including things like Qdrant, Weaviate, Milvus, Chroma, etc. There's a number of different vector databases out there that go beyond, the very, very core concepts here and do all sorts of other interesting things. So whatever your use case, there's probably an option for you. And Spring AI has a really nice hierarchy to support them. I almost wish that the Spring AI modules around vector databases were its own thing. It feels a bit like JDBC. It's one of those abstractions that's just so very useful in so many different contexts. But for now, it feels really natural that it would be in Spring AI. So my friends, that's what we're going to do today. Is we're going to take a look at vector databases and the abstraction in Spring AI. And in particular, we're going to look at it in the context of a Postgres application, a Postgres SQL database abstraction and implementation. All right, my friends, let's dive right into it. We'll start, as always, at start.spring.io. We're going to build a new application. I'm going to call this Beautiful Vector DBs. We're going to add Maven. We're going to add Postgres Vector Database, PG Vector Database. Now, mind you, this is just Postgres. In fact, if you're using the connection detail support in Spring Boot, you can have Spring Boot treat this just like a Postgres, right? So it'll actually automatically connect to it. It'll give you a Docker Compose file for it. It'll work with test containers, etc. out of the box. Okay, so we got PG Vector support, we got Docker Compose support, we've got Java 21, we got Maven. What else? Well, I suppose we want the web support, and I don't know, is there anything else? JDBC, sure, right? I'm not going to add Postgres because that's implied, right, in that support. Actually, it's probably implied. I think it's probably fine. So let's go ahead and leave all this as it is, and let's go ahead and hit generate UAO Beautiful Vector DB. So we'll open that up in our ID. All right. So if we look at compose.yaml, you can see it's just a regular Postgres instance. We're going to expose it on that port. And then, I don't want Spring Boot to constantly start and stop that database. So I'm going to say Docker Compose, just start it just one time and then leave it running. Okay. And I think that's the important part. We need some schema here. So, we're going to work with some data in a table called products. All right, let's go ahead and start this just to get the PG Vector database up and running. Okay, you can see it's using Docker Compose file. Container created, waiting for it to come come to life. Okay, it doesn't have an embedding client. Friends, here's a very important point. A vector database is a thing that stores numbers, matrices basically, about data and allows you to do comparisons using cosine similarity. But it's just, and by the way, this is a good point. We actually have a simple vector store in Spring AI, and you can actually see it's just an in-memory version of a vector store, thanks to these amazing contributors. That's doing some pretty, chalk on the board kind of math, but still just math, right? You go down here, most of the code here is just about marshalling and unmarshalling data to and fro. But if you look at the actual work, where is it? It just comes down to this math, right? Not all that crazy or scary, and it does do a great job. So the question then is, okay, if I've got arbitrary data, pictures, images, sound, text, whatever, how do I describe it? And that work of turning that thing into those numbers that I just described, that matrix of numbers, that is called an embedding. And somebody has to do that. And we don't have an embedding client on the class path. So let's go back to our build, and we're going to add one more dependency. Give us an embedding client. And here, you'll find that a lot of the different LLMs also have good APIs that you can use to create embeddings. So I'm going to add OpenAI, to the build, and you can see that that's here now. Okay, we've got Spring AI, OpenAI, Spring Boot Starter. I'll reload, and then I'm going to restart the program. Okay, there we go. So now we've got a Docker container with our embeddings and all that stuff. We got an embeddings client, and that embeddings client, if you look at the code, here's the abstract embedding client. We want the OpenAI embedding client. This client, in turn, is just talking to the OpenAI endpoint to do the embeddings, right? So we're sending some data over there. So this.embed, this embed, embedding request, and here we're going to call, embedding client.call. We're going to call and take this formatted content and then make a request. So here we go. Retry template, embedding request, sending that request to the API and getting back a response that we then use. So we're actually using this is one of the forgive me, vectors of competition between the different AI platforms, is that they all have different kinds of embedding. Some are more fine-tuned for certain kinds of use cases than others. And so if I'm using OpenAI in my AI application, in my RAG pipeline, I might as well use their embedding client as well. Whatever you use, it's important that everything you do be in the same vector space. That's important, right? You don't want data from this application being embedded one way and data from that being another, being embedded in a different way, because it's going to result in sort of incompatibility that's going to make it hard to find and work with the data in a consistent way. So I'm just going to use this because the assumption goes, I've already got OpenAI on the class path. I didn't in this case, and so, that's a bummer, but I need to have that, okay? Now, in order for this OpenAI integration to work, obviously, I need OpenAI, I need a key. But friends, I've already done that. I've already taken this property and exported it as an environment variable off screen. So forgive me for not leaking my API credential to you, but just trust me, that's already been done. And you know what? Actually, I don't even want to, I'll just leave the Docker image running. It's already running. I could have just done Docker Compose up for now, so I'll turn off that support. And the next time it runs, it'll just, I won't have to wait for Docker to do its thing. So 1.7 seconds, let's try that. Restart with everything on the class path. Okay, there we go. Oh, it still found the Docker image. So let's reload one more time. So now it's complaining that we don't have the credentials to the database. That's true. So spring.datasource.password, secret, username, my user, URL, JDBC, PostgreSQL, localhost, my database. Okay, restart again. There we go, 1.1. So that 0.6 seconds, that was just the work to interact with the Docker Compose daemon before. I'm happy to have those at 0.6 seconds back in this case. Okay, now, our database, it exists. We know that, right? Here's the, let's create a connection to our database, test the connection. Looks good. Okay, hit apply, hit OK. Go here. Refresh. Okay, you can see we have the vector store support. Okay, let's go refresh. Tables, we got the vector store. You can see it's empty, but you can see this is what the OpenAI support for, you can see that this is what the PG vector support in Spring AI looks like as we create that table for you in which we expect to place vectors, okay? All right, and you can see they got ID, content, metadata, and the embedding itself. And the embedding itself is of type vector of 1536, okay? So that's pretty straightforward, right? We just have a table for vectors there. Now, let's go ahead and put some data. We need some data with which to work, so I'll put some data in another table. I happen to have a SQL file here off to the side, cat desktop dump, and head. There we go. You can see it's just a PG dump from a lot of SQL. Okay, so I'll do PG password equals secret SQL my user h localhost my database cat desktop dump. Okay, oops, wrong host. There we go. So I've got a table there. Refresh. There's my products table. And you can see I've got some product data here. I've got the description, the SKU, the name, and a price, okay? And I want to search the vector database for similar products given a particular product, okay? So we've got the data in the database. I've seeded the database. I could probably put that database SQL dump file here in there, okay? And that way it's there for you if you want to try it out when you run the code. And now I want to just talk to it. So let's say I create what does our schema look like again? It's got ID. So we got product. So it's int ID, string name, string SKU, string description, and float price. Yeah? Okay, good. So voila. Okay. And we want to create a simple, let's say, product service. Okay. Actually, you know what? Keep it simple. Very, very simple. Let's just keep this all in one place so we can kind of see the moving parts, right? So, new application runner, close that. I'm going to use the JDBC client here, which is going to have a data source already, a reference to that. And we'll create a vector, we'll inject the Spring AI vector store implementation. So first things first, let's just prove that we can get all the data back out of the products table correctly. So select all from products dot query new data row mapper, and then list it, right? And then dot for each system out print line. Okay, let's just see what that does for us first of all. Hello products. Okay, I want there you go. Restart this, and it has failed. That is so sad. So sad. Let's see here. Mapped constructor was not initialized. Oh, I forgot to specify the type. Products.class. There we go. Okay, so we got product ID, name, casual pink sweater, SKU, blah, description, blah, okay? So we want to take this data and put it into our vector database and then use it to find similar results, okay? So now that we know that that works, products, this, that, okay? Now that we know that that works, let's go ahead and write these records to the vector database. So for products, what did I say here? To list, okay? Vector store dot add. And we want to add some documents. Well, what are these documents? Well, we need to describe the payload and metadata associated with each thing. But also, I want to parse the string itself to make it more natural for insertion into this vector store. I'm going to use a bean of type token text splitter. Okay, and I'm going to inject this. What is that bean? Well, I have to create it. Okay, and now we'll say token text splitter dot split. So we're going to take the text and we're going to apply this, okay? And so we need to create a document. var document equals new document using Spring AI document here. Passing in the content. For me, I think that it makes sense that that would be the product name and the product description. And then we want a map of keys and values, right? So the price is, these are just metadata, things that we want to be able to find the original record in the products table eventually, right? So the ID, product.id, the SKU, product.SKU, and what else? Description, I guess the name, product.name, etc. You can put all the stuff in there. Only the content figures into what gets searched, right? Okay, so I'm just, all this extra stuff is just, well, it's just that. It's extra and it's not required at all. Okay, product dot description, etc. Okay, so there's my document. Okay, my single document. I'm going to pass that into here, like so. It's a list.of. Okay, var splitter and that. Okay. Okay, so now what do I have? Split. Okay, so it's a list of documents that I'm going to split. And now I want to write these to the database. So I get my vector store and I say add or accept. It turns out they are synonyms. So accept calls add. All right. So I'm going to call add, passing that in. And And that's it. That's the hard part. I've already done I've already, set up my data in such a way that I can then use it. So let's try this. I'm going to put this behind a Boolean here. So private final Boolean ingest, let's say. It'll be true this time. So we'll say if this dot ingest, and then put that in there. Okay. So we're going to run it this one time, but I don't want to run it again over and over because I don't want duplicative data, and we haven't done the hard part yet. Okay. Okay, let that do its thing. It's running, and you can see it's taking its time because behind the scenes, it's making network calls, right? You could make this a little faster if you don't mind the potential risk of possibly rate limiting yourself, which is to do things concurrently, right? So if I go here, let me stop this, refresh this to see how far we got. We got to 118. For reference, I have 500 records in the I have 1,000 records in the products table. So let's drop this vector store database again. Okay. Spring AI will reinitialize it. I'm now going to rework this to do concurrency. I'll use a fork join pool, right? So I'll say products stream dot. I want parallel stream, right? Parallel stream dot for each, and then here we'll write the data to the database. Okay, there we go. Very good. So now we're gonna you might get rate limited, so careful. You don't want to do this all the time. Remember, you're making network calls too. This will cost money if you're using OpenAI or something else, but I'll do it for you. For you all, no problem. This one time. Okay, so here we go. We're going to reload, and there's my products table and my vector store database table. And you can see we're moving a lot quicker, right? I've already got 500 rows here. I've got 931. Okay, there we go, 1,000 rows. So it's successfully written the embeddings for all that. Let's go ahead and, just so I don't forget, I'm going to make this false so we don't get another run. Okay. And we can hide that. Okay, good. So now, friends, let's take a look at our vector store here. It's very, it's nice because it's very opaque. You can kind of look at the data here. It's an embedding, right? Remember, what did I tell you? It's just math. So lots of data there. And this is all pretty straightforward text, right? The descriptions are, winter purple dress, perfect for casual outings, and the size, and dry cleaning, and all that kind of stuff, okay? So now, what can I do? Well, I can look for similar things. So let's say I find a description, I like, and then, spring, nothing. What about shirt? Maybe it's this. Okay, so let's try name, okay? Okay, so you got 104 shirts. We got winter shirts. So let's say, is there anything for spring? The better be. Oh, that's wrong. That's just wrong. Look at that. All these winter appropriate garments, but nothing appropriate for spring. You know why? Because everything's appropriate for spring. Okay, so let's just say we want to look for item 57. Yeah, okay. So let me get the product here. This is useful in general. So put that here. Very good. I'm going to close this. And then down here, I want to get products.stream.filter product.id equals, what do we say? I don't know. What's a good example? 115, I guess. I don't know. Let's just try it, okay? So to list dot get first. Okay, there's that. Good. And we're just gonna get the very first record, and I want to use that to then find other things that are similar to that. So do a similarity search. We'll pass in the query there, single dot name and description, right? So single dot description var similar. Let's see if this comes up with anything. For var toString. And by the way, the results that I got back are documents again, remember? So we're gonna keep that in mind. Hey, look at that. Okay, so I did a similarity search for this one record whose ID is 115. 115, whoops. Oh, in the product, right, products table. So 115 over here, right? And so it's winter gray pants, perfect for casual outings, formal events or homeware, stretch fabric. Okay, and so how many results did we get? Looks like a fair number, right? It's not like endless. So we got, let's see, winter gray pants. Of course, that might be the one, actually. That might be the very first. Yeah, it's the thing that most matched is 115. Okay, checks out. What about 553? Okay, perfect for casual outings, formal events. Looks like it's got all the same sizes. Comes beautifully packaged, ready to gift. Stretch fabric provides excellent comfort and flexibility. Perfect for casual outings, formal events, okay? And it's called formal gray pants, all right? Okay, very similar, very, very similar. And the price, we didn't factor that into the search, but that might be something else. Warm gray pants, okay? So this is pretty similar, but you know, the question now is, how similar is similar, right? We don't actually know that from those results. So let's break down some of the information that we're getting here, okay? So s.get metadata, okay? Dot for each kv, kv, okay? And system s dot get embedding, that's the list of doubles, get the formatted content, you know, that could be interesting as well, but I don't really want that. I just want the metadata, and I want the ID, right? So var, actually, let's just do that. Var ID equals this, and it is an object. We don't know what type, so let's just say ID is ID, okay? And then I'm gonna print out the metadata associated with that record. So, okay, and then, you know, just let's print out count of related results, similar to that size. All right, we got 4 records, okay? ID 115, 115 skew, blah, 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 of course. You would do whatever you could to exclude the thing that you're looking for, right? Description, okay? And you can see the distance here, friends. See that? So the distance away from the thing you're looking for is a measure of how similar it is, right? So 0.05, 0.07, 0.08. So I guess the distance is, the larger the distance, the further away it is from what you're trying to do, right? So that's pretty good. Look at that. We got some very similar results. And this, of course, is how you would take from a forest of results, a haystack full of results. You'd find the things that are similar, and then you could use that and say, okay, hey, OpenAI or Gemini or Mistral or whatever, given these 5 results, help me find the thing I want based on the user's question. The user's looking for something that's appropriate in warm weather. Here are the things I found that are similar to their existing search query. Give me some results. So that's, you know, the essence of RAG, right? Now, okay, I'm using the name and the description from the existing data. Maybe I don't want to base it on some existing data. Maybe I just want to look for random, you know, let's see, warm weather and cold weather. Let's see if that gives me something similar. Okay, there we go. It looks like it did. So we got 4 records back: cold yellow jacket, cold yellow gloves, cold green jacket, you know, okay, good. So we get some similar things like that. And then, of course, if I wanted to, I could also send a search request. So a search request query, passing in, you know, cold weather, right? And I could do with similarity thresholds, with filter expressions, with top K, you know, 10 records, for example. Okay, there we go. So I got now a lot more records back, looks like. That gave me 10 records back. So it's the top K, 10 records. So you can, I think by default, you get 4. Is that true? That feels arbitrary, but okay, sure. Yeah, look at that. It's 4 by default. So it's actually giving us more or less depending on what we're asking for. This is really cool. I hope you see the potential here. And of course, you would sort by the distance, right? So the things that are closest to what you're looking for, you would preserve, and the things that are furthest, you jettison. We've only begun to scratch the surface here, obviously. This is, you know, you can use these embedding clients. You can use other embedding clients with this. You don't have to use OpenAI, but bear in mind, these are usually hosted services, but vector databases themselves aren't, right? And a lot of the vector database drivers that we're looking at here will also have their own embedding client. It just so happens that pgvector doesn't, right? The vector DB support in Postgres doesn't have its own embedding client in Spring AI. So you're encouraged to use somebody else's. But if you're using, you know, a particular vector database, they might have their own vector support, vector space encoding support. I hope you got something out of this. As always, thanks for watching, and we'll see you next time.